And we're back. Oh, I got to hit out the guided notes. So we are looking at the second day of section 5.3 today, right? This is the second day of elimination. Remember that our quiz is on Friday, the day after tomorrow. Let me remind you, that is the last chance to pull up your grade. So you might want to do that before the end of the semester. Remember that your ornament, please turn that in by Friday. If you need till Monday, that's fine too. But again, you'll see that in the grade book, there isn't a spot for it because people have already started turning them in. Let's put those in as soon as you turn them in. All right. Now, this first slide is the exact same thing that we talked through yesterday. Okay? Literally the exact same graphic. But what I'm going to do today is talk you through what's going to be different about today than it was yesterday. Now, first step, multiply if necessary. Did we have to multiply yesterday? Yes. A little bit, right? At the end of the lesson. But a lot of them were set up for us. Today, we're going to have to multiply every one of them. Multiply if necessary. Now, we only multiplied one equation, right? Well, every time we did it, we only ever multiplied one. Like this number 11 that we had at the end here. All we did was multiply the bottom. Now, we're going to be multiplying both of the equations. That's what's going to be different about today.
Like the equations, you have to balance them out like multiplying.
Oh.
This is the same thing.
Gio said, oh, thank you, Gio, for clarifying.
But what we're doing in science is like math.
Is it like
It's just chemical equations.
Chemical equations. That's what I was going to say. Chemical equations, yeah. Who do you have for Mr. Laubach? You know, I think he used to be a math teacher. Like long
He
time.
told us his first 5 years of his 80-year career.
Right. How many years did you say?
80.
30. 45. All right. So now what we're going to be doing is multiplying both of the equations by a constant. Remember, we crossed out this constant, so at least one pair of like terms has opposite coefficients, right? That's what we're really doing here. We're getting them to be opposites so that we can add the equations. Because again, we don't subtract. I did teach subtraction in my first couple of years. And you know what? It's a train wreck. Because if I let you do subtraction, that means that you have the option of putting the numbers the same. But if you don't distribute that subtraction sign when you go to subtract, it all goes to crap. So I think it's better. I've seen that it reduces some of the errors if we just say make them opposites so that you only need to add. I don't think so. Hi, Mrs. Kalala. Yes. I will send her. Yep, bye. You called? You knew. You called.
Yeah.
Now, steps 3 and 4 are the exact same thing as yesterday. We're not changing steps 3 and 4. The only thing that's going to be new about today is the fact that we're going to have to multiply both equations. Let me show you what I mean. Now, I'm going to actually do this problem twice. You're going to do it with me the first time, and then you're going to watch me do it the second time. Here's why. Let's take a look here. Let me ask you this first off. I guess we should go through this process. Is there anything I can multiply 2 by to make it look like 3? No. Is there anything I could multiply 4 by to make it look like 5? No. So this one, I cannot just multiply one of the two equations. I'm going to have to multiply both equations. So if we choose to eliminate with the x's, and it's all choice at this point, you could, once you see that it doesn't eliminate correctly, or doesn't eliminate conveniently, you're going to have to multiply both equations. You can do whatever you want. What number could I get these easily both to? 6. The least, look at you, Brennan. The least common multiple. That's what you're looking to get. The least common multiple. So let's do that. What do I multiply the top equation by?
3.
What do I multiply the bottom equation by? 2. Now, we just have to make sure they're going to be opposites. Are they going to end up being opposites? Yes, because one is positive, one is negative. Yes, Sid.
So what would happen if you didn't go to that? Because you could do...
Yeah, see, that's why I'm going to do this a second time, and you're just going to watch. So hold that thought. Now, we just multiply in the 3. We get 6x. We get 15y. We get 78. Look at the bottom. Negative 6x minus 8y, negative 50. See, like I said, when we had multiplied one or both of the equations, the numbers tend to get a little bit larger. Don't let big numbers scare you. It's going to be okay. They tend to even out in the end. Like, for example, here, this is going to end up getting us 7y is equal to 28. And that is a very easy equation to solve. That's just 4. Now we plug it back in. Let's go into the top. 2x plus 5 times 4 is 26. 5 times 4 is 20. We subtract 20 from both sides. We get 2x is 6. Yes?
Why are we plugging it into the equation that's multiplied by 3 or 2?
You can. You could plug it in to the originals or these equations, because aren't these equations just scaled up versions of the originals? So it doesn't really matter. I like to go into the originals because they're the scaled down versions of, they're just the originals. Yeah.
I have 2 questions.
First question.
So
Let me just write the answer as you're talking the question.
So, like, how do we know after we get, like, the y value or, like, the x value what equation to put it into?
You can pick.
You can pick, it doesn't even matter.
Yeah, I would go back into the originals,
Yes, sir.
and then it doesn't matter which one you pick. I just picked the bottom, or the top, excuse me.
Good question, Gio. W.
And then, like, another question is, like, what if, like, there's 2 of them, like, on, like, the top, and they are both smaller than the x and the y value on the bottom, but, like, you could multiply them by the same thing for both of them and get,
Ooh, and then they would both cancel out?
Yeah, then they both.
That's something that we discussed in section 5.4. You're not going to have anything like that right now.
No.
Yeah. But when that happens, a unique happens. Actually, when that happens, just a little foreshadowing, the lines are parallel.
Right.
That's when they both end up canceling out, the lines end up being parallel. Yeah. Okay, now, I said I was going to do this problem twice. So if you copied that down correctly, you can just watch now. Let me clone this page. Yeah, that's what they call just copy and pasting. And then I'm clearing from page. Now, what did I do the first time? I eliminated the x's. Let's eliminate with the y's.
So it'll be 2, and that'll be 5.
2 and 5.
Oh,
Okay.
the Y, come on.
What is the value that I want to get to?
Oh, we're doing the same.
20, right? Because listen to me. Because as soon as you notice that you're going to have to multiply both equations, then you could get rid of the x's or the y's. Okay? This is the hardest version of elimination, where you're going to have to multiply both equations. Okay? And I find this easier than substitution, but again, I'm going to make you do both. You got to learn both. So the top equation, what do I multiply by? Bottom?
-5.
Positive 5.
Oh, my bad.
They're already opposites. So this would become 8x plus 20y is equal to 104. The bottom becomes negative 15x minus 20y, negative 125. Now we add down. Negative 7x, negative 21. And look at that. Didn't you just write down the x value of 3?
Mm-hmm.
But that was the second one that we found. See, it doesn't matter. You're going to get the same answer either way. And then obviously I would just plug that 3 in to find the other, the y coordinate.
Couldn't you do that and take their original and do what we did before with the 2 and 3?
Sure, yeah, I guess you
Like,
could. Yeah.
get x.
And then get y.
X, you get y, and you again eliminate y and get x.
Yeah, you can do that.
So,
Yeah.
See that? Some in science, these girls trying to take out me and Noah's flow with the fist bump, so we made our own handshake. You want to see it? Boom, he's gonna see it anyways.
That's so cool.
Did that just happen?
Oh yeah, and Mr. Laverick, in science we're doing a Lake's Common Multiple too, so it's like the same thing.
Exactly.
We're also blowing up the cheese.
Has nothing to do with that.
Yeah. And it's literally
We're on a lap today?
I just thought every time I get an answer, I made Noah fist bump. So
No.
Yes, it.
So how you had to multiply to get like 6 and 20. What if you were to do both of them? So if you were to get 6x, negative 6x, and then you were to get
you
like
can't do that.
20.
See, as soon as you have to multiply the entire equation by the same number, right? So you can't multiply each piece by different ones. I think you're actually asking the same thing what Gio asked. Like, what happens if it ends up that like they both end up canceling out with the same number? The lines would end up being parallel. All right, let's take a look at example B. Now, I could eliminate with x's or y's here. But I don't know, when I have an option, I like to go with ones that are already the opposite. Like, do you see how the y values are both positive? I know I'm going to end up having to multiply by a negative in my y values.
So it's going.
So let's go with the ones that are already opposites. What number should I try to make these? 10. Which means I multiply the top equation by 2 and the bottom equation by 5. So let's distribute in. This becomes a negative 10, a positive 4, and a 64. The bottom becomes a 10, a positive 10, a 15y, and a 50. See, again, the numbers are going to get big, but they should reduce down nicely. Let's add down. This gives me a 19y is equal to 114. And I hope that 114 divides nicely by 19. It does. It's a 6. Y is equal to 6. Now, let's go back in.
We do the bottom one.
Sure.
It's way easier.
2x plus 3 times 6 is 10. Well, 3 times 6 is 18. Subtract the 18. And then we divide by 2. So negative 4 comma 6. And that honestly, the only additional thing that I could do is make you reorder it. Like, maybe I gave you the top equation like in slope-intercept form, and you had to get the x's over to the left side and leave the constant on the right, and then choose to eliminate. That's the only other step I could put in front of it. But honestly, why would you do that if it was slope-intercept? Because well, then I could just do substitution, right? Like I said on the quiz, on the quiz on Friday, the ones that I'm going to give you for substitution are going to lend themselves to substitution. The ones that I give you for elimination are going to lend themselves to elimination. The ones where I ask you to choose, well, then you have some options of doing whatever you want. And if one is already set equal to y, are you really going to choose to do elimination? No, you're going to choose to do hopefully. you're going to choose to do substitution. Okay? And like this, would you ever choose to do substitution for this? I mean, like, nothing is easy to solve for, right? Nothing is alone. So I would never give you a problem like this and tell you to do substitution on it, because nothing's going to come out nice. Okay. All right, last problem here, word problem. We got donuts. We've got cream sticks and glazed donuts. And we've got two people. I've got two orders. Trent buys 3 cream sticks and 4 glazed for $6.75. Zach buys 5 cream sticks and 2 glazed donuts for $7.75. What we're going to look for is see, okay, well, how much does each donut actually cost then? Maybe they like didn't give our receipts back to us. But then somebody was like, well, how much did that cost? How much was a cream stick? So let's create an equation. One for Trent and one for Zach. What is Trent's equation? Sid?
I'm guessing 3x plus 4y equals 6.75.
Yeah, where x is the price for the cream stick and y is the price for the glaze. So therefore, Zach's, we set up Trent's pretty easily. Zach's 5x, 2y, 775.
We have the same number of carbs and calories, but Zach paid more for it.
I don't know, because
I don't know. The cream sticks got
cream sticks are
I don't like them.
Kind of up there.
Yeah,
I don't know, man.
All right. Now, if I were to try to eliminate with the x's, I got to do that whole multiply both equations thing. Do I need to eliminate with the x's?
Are we gonna have one of these?
Listen, stop. Do we need to eliminate with the x's? No. I can eliminate with the y's. Do I need to multiply both equations for the y's? No, just 2 on the bottom. All I need to do is just multiply, and I should be careful. I need to make them opposites, right? So I'm going to multiply by -2 on the bottom.
Does it matter if, like, you know how you have a 3x and 4y? Does it matter if they're switched?
Yes.
Why does it matter if it's a negative?
So how do you know which one?
Because they're both both positive, right?
Yeah.
So I need to make them opposites to correctly make them cancel each other out.
Okay.
One needs to be positive, one needs to be negative. So therefore, if to make this one a negative, I just multiply by a negative.
I see.
Does that make
So
sense?
like you need the 4y, you need to cancel out the 4y
Exactly.
with the negative 4.
Exactly.
So is there gonna be something that tells us what x and y is, or are you just gonna have to like? See?
Well, no, I'm just saying if you wrote 4x plus 3y, then you can't write 5x plus 2y. You would have to have those flipped
That's
as
what
well.
I'm saying.
Then that's fine.
Okay.
Now, top equation remains the same. 3x plus 4y is 675. The bottom equation is -10x minus 4y. And then 775 times 2 is a -15.5. All right, now I add down. -7x. 675 minus 15.5, 875. -875. We divide by -7. So x is equal to $1.25. So that means each cream stick was $1.25. Each cream stick was $1.25. Now, let's go back into one of our two equations and solve for the glazed donut price. Let's go into the bottom. Again, that doesn't matter. We want to take 5 times $1.25. Plus 2y is equal to 775. So 5 times $1.25 is $6.25. We subtract the 6 1/4. So 2y is equal to 1 1/2. We divide by the 2. So y is 0.75, which means, so I had $1.25 for the cream sticks and 75 cents for the glazed.
What is your favorite donut? You seem like just a plain no icing guy.
I feel like it's like maple bacon.
Just a
No,
donut.
I don't get it. I think you're just gonna be like. I think you're like a plain guy. It's just like.
No, I like chocolate cream stick.
I feel like you're a white powder.
There's what?
No,
My favorite is the
Or like an
strawberry-
apple fritter.
like apple pizza.
Strawberry sprinkles are the best.
Strawberry? No, I don't like the fruit stuff.
Pig frosting.
Yeah.
Oh,
those
it's
are
so good.
That's the best.
God.
That hits home, man.
And the chocolate. That's
All right,
like
quiet.
okay. Like the strawberry one.
So, that's elimination where that's like the hardest type of elimination where you have to multiply both equations. Let me pull up the homework real quick to show you. Again, it's on the same page. I didn't change the page number. Now we're just more in this bottom section. Like there are going to be some where you still only have to multiply by 1. Like 10, you only have to multiply 1 equation. 12, you only have to multiply 1 equation. 13, you're going to have to multiply both. 14, both. 15, both. So 3 equations you're going to have to multiply both. Then 18 down here is the word problem. Okay?
Hey, what do you wonder?
Hey, Mr. Laverick. I finally bought a calculator.
Why is there an expiration date on it?
Bought a calculator.